Okay, so one thing in this unit is percent increase and decrease. So that is looking at how something is increasing or decreasing in value. Okay, so the calculation that we do is right here, percent change. So we always take the new value and we subtract the old value, and then we divide by the old value or the original value, and then we just times it by 100 to put it in percent. So for example, I have a table here and it shows a company's profits over 5 years, and it wants to calculate the change in profit from 2005 to 2006. So in 2005, the profits were 186,000, and in 2006 they were 364. So I could see that the percent is going up, right? I'm having more profit, so I want to figure out the percent that it's increasing by. So we always take the new value. So this is the old value, and this is the new value. Okay, so I'm going to take the new value. Oops, I don't need that. Take the new value and subtract the old value. So that's the difference in the profits, right? How is it changing? And then we're going to divide by the old value, the original value, and then we're going to multiply that by 100. Okay, so I'm just going to figure that out on my calculator. So we're going to take 364,000 minus 186,000 is 178,000. So that's how much it's increasing by, and compare that to the original value. And then multiply that by 100. So 186, oops. Times 100. So that is 96%. Okay. So you can see it almost doubled, right? Double would be 100% increase, so it's almost doubled, so 96% increase, okay? Change in profit from 2007 to 2008. So this is the old value. This would be the new value. So we're going to take the new value in 2008 is 212. Subtract the old value. Old value is 728. And then divide by the original old value. So I can see that the profits have gone down from 2007 to 2008. I went from 728,000 to 212, so it's going to be a negative value, right? Because it's gone down. So we will subtract 212 minus 728. So it's a negative value. Compare that to the original value. So we'll divide that by 212 and times 100. So it's gone down by negative 243%. Okay, so percent change is always compare the new value to the old and then divide by the old. Okay, so that was just a little bit of calculation. So a lot of this lesson today is about collecting and organizing your data. So once you have figured out a survey, right? So we talked about surveys the other day and what we want to look for and what makes a good survey. One thing they talk about is primary data and secondary data. So primary data is data that you collect yourself, right? So maybe you do a survey in the school, you ask people directly, and you're collecting or observing the data. Secondary data is data that you are going to get from somebody else, right? So maybe it's Statistics Canada, right? That's a really good website where it gives you lots of information about Canadians, everything about them, work, entertainment, salaries, housing, all that information is on Statistics Canada, right? So if you want to see where all the good jobs are or how much money you're going to make in a job. You can find that all on eStat. So that's a good source of secondary data because it is reliable and it's easy to access. So we will actually be using eStat when we start to look at finding a job and going to school. Okay. Okay, so a couple of questions you might want to ask. Is it possible to collect primary data when the population of the survey is every person in Canada? So if you're trying to collect data from every single person in Canada, that would be a hard job to do because it's really difficult to ask every person in Canada, right? So that is difficult because there's too many people. Right? One time they do it is a census, right? So a census is where they ask every single person in Canada to answer some questions about their household. The problem with that is that not everybody answers the survey, right? So they'll mail it to you, and then they hope that most people will answer it, but not everybody does. So that is primary data, and that data that they collect in a census is actually used on eStat, but then it is dependent on how many people actually answer the survey, and not everybody does, okay? The disadvantages of using secondary data is it's not always reliable. So I would compare it to if you heard a rumor about your friend, if you asked your friend directly, then you're going to have a reliable source of information because you're asking them directly. If you ask a buddy about your friend, that might not be reliable, right? That's secondary data, so that might not be a reliable source because they might not be truthful, right? Or they might exaggerate, or they might not tell you the whole story. So that would be an example of secondary data. Okay, so it's not always reliable, and it has to be a good source of information. The advantages of using secondary data is it's easy to collect, right? It's an easy source. It's easy to access and collect, right? It's already there, right? So you don't have to do the legwork. You don't have to go out and do the survey or ask the interviews. It's already there, so it's easy to access that information. Okay. So this is just some examples of some situations about data collection. So we talked about surveys, and we talked about what makes a good survey, right? The questions and the way you present it. You also want to make sure that when you're collecting the data, that it's accurate and fair. So in the first example, Brianne is watching cars at an intersection for 10 minutes, and then she's making an estimate on how many were red and making a conclusion from that. So what do you think the issue might be in that survey or that collection? What do you think? You think 10 minutes is long enough? So if you wanted to make a observation and conclusion on how many people owned the red car and you sat at a corner for 10 minutes, would you think that would be an accurate, might be a reasonable estimate, right? Counting, but you might want to either stay longer or you might want to come back on another day, right? So you're only getting a small snapshot of, it's kind of like when you do blood work. If you went and get your blood taken and they did all these tests, you're only getting a snapshot of what your blood work was that day. You're not getting it like for the whole year or the whole month, right? So you're only getting it for a small snapshot of that. So I would say might want to stay longer. Or go back on multiple days. Because maybe it was a weekday, right, where there's lots of traffic, or maybe it was a weekend where there's not very much, or so you want to go back on more than one occasion to get some more accurate information. Okay, Henry asks all the friends he sees at the food court which restaurants they like the most. So again, your data or your collection, you're only asking the people that you know, right? So you're getting limited information because you're not asking everybody that's going to the food court. So your friends probably only like, New York fries and Subway, right? But they not a good representation of all the people. So that would be not a good representation of the population. So it's like I was talking about, if you did a survey at Westmount and you wanted to know people's favorite food in the cafeteria, you would want to ask people from all grades, right? Grade 9, grade 10, grade 11, grade 12, and all genders as well, right? You want to make sure that you're asking the whole population and not just your buddies, right? Because you're only going to get a limited opinion if you only ask your friends. Okay, once the data has been collected and organized, the next step is to analyze it and then write an equation. So you're going to do a survey, you're going to collect the data, and then you're going to plot the information onto a scatter plot. So we've already looked at scatter plots. Then you're going to draw a line of best fit. So remember that a line of best fit, you're going to draw a line through as many points as you can. That will give a good representation of the data. It does talk about linear correlation. What that means is how good your line fits on those points, right? So you might, the closer it is to 1, so that's really the slope of the line, is the better the fit. So it's sort of like this. If I had a bunch of points and I did a line of best fit through as many as I could and through the middle, and then maybe I had some data that looked like this. Right, this one's going to give me a better correlation because all the points are closer to the line, whereas this one are more scattered. So this one has a better correlation. It's probably closer to 1. So I don't know if you remember back in grade 9, but you probably did. You might have used graphing calculators. Maybe not. Maybe that's too long ago. We used to use graphing calculators, and you could put all your points or all your data into the calculator, and it would make a line of best fit for you. And then it would tell you the correlation factor. So it would tell you whether it's close to 1 or not, but we don't really use those anymore. So that just is the correlate. And we talked about correlations earlier. We talked about positive correlation, negative correlation, no correlation, or you could have a strong positive, a weak positive, right? So this would be a weak positive. This would be a strong positive because they're more close to the line. Okay, so once you've collected your data, so here someone's collected data on fast food and they're comparing the total number of fat grams and how that is related to how many calories are in the food. So their hypothesis is the more fat grams in the food, the more calories that food is going to have. Okay, that's the relationship that they're investigating. And so what you would do, so here's our independent variable is fat, right? That's my x. And this is my y. And so the number of calories is dependent on how many fat grams are in that fast food. So those are my independent and dependent variables. And then we're gonna plot these points onto a scatter plot. So my x would be total fat, and my y would be total calories. Okay, so if you give me a minute, I'm going to plot these points. It's going to take me a minute. So 9 to 60. So 9. It's hard to do on a. This is going to take me a while. Okay, 13, 320. So 13, 320 is 1, 2, 3, 320 is here. 21, 420. 21, 420 is there. 30, 530. 30, 530 is there. 31, 560 and 550. 31, 560 and 550. 34, 590. So we're just plotting the points. 590 is way up here. and 25,500. There. 28,560. 28,560 is there. 2440. 2440 is right there. And 5,300 is the last point. 5,300 is right there. Okay, so there's my points. Okay, so I plot my points on a scatter plot. The second thing you want to do is make a line of best fit. As we talked about earlier, your line of best fit will be different for everybody because it's sort of your estimate of where you think it is, but it should be close, right? So when I'm looking at your equation of your line of best fit, it should be fairly close to what everybody else has, right? It shouldn't be completely different. So my line of best fit, I'm going to try and go through the middle. So let's do it something like this. Okay, so my line of best fit is going to look something like that. I'm not hitting a lot of points, but I am trying to put the points equally above and below that line. Okay? So once you've done that, so position a ruler so the points are as close to the ruler as possible. Find 2 points that you think will be on. So your 2 points you pick on your line of best fit don't have to be data points. They can just be on that line. So they should be on the line, and then we're going to calculate the slope. Okay? So, and we like to do it fairly close to the end. So at this end, this point is actually on the line. That point is, what is that point? 34,590. So I'm going to use this point. That was actually one of the data points. And then I'm going to use one point down here. So maybe I'll use this point because that seems to be on a grid mark. So that point is 3 and 240. Okay, so that wasn't actually a data point, but it is on the line. So now we're going to find the slope of the line. So remember, it's y2 minus y1 over x2 minus x1. So this is your rate of change. It doesn't matter which line or which point is which. I'm going to call this one 0.2, and I'm going to call this one 0.1. So I'm just going to subtract 590 minus y1, which is 240, over 34 minus 3. So your slope can be a decimal, okay? It doesn't have to be a fraction. So I'm just going to do 590 minus 240. Should be able to do that in my head, you think. Over 31. So we'll divide that by 31, and my slope is 11.3. Okay, so that's my rate of change. What does that mean? So the slope is 11.3. What does that mean? Well, I can see what it means by looking on my graph to see what I'm measuring. So the total calories is on the y, right? So that's what this is. This is total calories. And the x is total fat. So what this 11.3 means is that it's total calories measured to fat grams. So there are approximately 11.3 calories for every fat gram in that fast food item. That's what that means, okay? The y-intercept, you can do one of two ways. Well, you can look on the line, right? You can look on the line. That's probably the easiest way. My y-intercept is approximately 220. So if I were writing an equation, I could say so approximately from the graph, it equals 220. Okay, so I just extend the line. I just make sure that the line extends and crosses the y-axis, and I can approximate it approximate it from there. So my approximation is 11.3 times x plus 220. So this is my slope. This is my y-intercept. You could measure it. You could figure it out algebraically. So we could say that we know the slope is 11.3, and we could pick one of our points that we used. So either 3,240 or 34,590, because they're both on the line. So I could say if it passes through the point 3,240, which is my x and y, I could put y in for here and x in for here and figure out accurately what it is rather than estimating. Okay, so if you're looking at the graph, you're estimating. If you use the equation with the slope, then you are probably going to get a more accurate answer, and it should be close. So 11.3 times 3 is 33.9. And so I'll just subtract 240 minus 33.9, and I get 206. Right? So it's close, right? 220. This is more of an estimate, whereas this is more accurate. Okay? So this would be fine. I would be okay with that. You could also say so this was from the graph, and this was algebraic. Right? So whatever way, if you know how to do this, great. Some people don't get confused by that, and you just want to look at the graph, that's fine. Or you can do it algebraically by subbing in a point here for x and y and finding b. Okay, which you did in grade 9, right? You remember doing that? Okay, once you have your equation, then you can use it to answer any questions. So it says, use your equation to estimate the total calories based upon 22 grams of fat. So I would use, let's use the one that we did algebraically. So this is my value for x, right? X represents fat grams. And then I could figure out how many calories are in that fast food item. Equals plus 206. So I'll probably have approximately 455 calories, right? Based on my, so that's a whole, if we were actually in school, I'd probably get you guys to do that. So you would do a survey measuring, you know, where you want to answer some sort of question. You would collect data. You would make a scatter plot of your data. You would make a line of best fit, and then you would answer some questions on that line of best fit. So one of the common questions we did last year was the relationship between your mark and how much time you spent on homework, right? Or some people use cell phones, you know, how much time you spend on your cell phone, and does that have a relationship to how well you do at school? So there's lots of things you can measure, but we're not going to actually do that. So the assignment that's in your guide, we're not actually going to do that assignment, right? You'll just walk through this example, and then you'll get asked similar questions on your task, okay?